In this lesson, we will continue using the same file to explore the use of flanges and bend overrides. We already used the flange tool to create features from sketches, but the flange tool can also be used to create features from edges on the model. With Body 2 active, start the flange tool from the Create pull-down. Then select the lower edge of the top face on both ends of the part and drag the arrow down to start creating new flanges. Before finalizing the new feature, let's take a look at some of the options. Looking at the front face on the view cube, you can see that the bend is being added and the corners where the new flange meets the existing body are being held back so that the outside face of the new flange is flush with the end of the existing body. In the dialog, we can change the bend position so that the bend is outside of the original selected edge, a tangent solution, or for this design, we will use the adjacent option, which will build the new feature without cutting a miter for relief. It's important to think about how the rest of the part needs to be built when selecting options. These new flanges will eventually fold and set on top of the previously existing plate so that fasteners can be inserted into the sheet metal, which will connect to screws passing through the holes in the base plate. In the previous exercise, we used radiused corners in the sketch to define the bends. By creating new flanges from the model edge, we can't simply add new sketches to get the same radius. We could update the sheet metal rule, but that's not always the proper approach either. Instead, we can select Bend Override in the dialog and set the value to be 5 mm to match the previous bends. As soon as the new value is added, the part will update showing the change. It's also possible to use named parameters to control the radius of the sketched bend and the bend override, but for this part we'll simply enter the values manually. We also need to establish the correct height for the new flange, which is the distance the sketch was offset plus the thickness of the material, so it needs to be 52 mm. Entering the value updates the preview, and we can see that it's perfectly aligned with the top face of the base plate. Changing our view to see the other selected edge, all of the same rules have been applied to it, so that now we can say OK to create the new features. Now we can begin creating the flanges that will go on top of the base plate by selecting the lower inside edges of the flanges we just placed. As soon as the second edge is selected, we can begin pulling the new flange in, and you will see that both are pulling away from the selected edge in the same manner, even though that means they are developing toward one another. Looking at the bottom view, we can make sure that there's enough material being added to go around the holes in the base plate. We should also make note that the radius that's being applied is again the default based on the sheet metal rule. This smaller radius is just fine, so we will leave it as is. If we decide we wanted to make yet another radius 5 mm, it might be better to just update the sheet metal rule and allow the previous bends to follow it to simplify things for manufacturing. Looking at the part from the right view, we need to make sure that the new flanges are being developed in a way that won't require complex cuts in the flat pattern. So we'll set the bend position to inside to make sure the edges of the new flange and the last flange remain aligned. We will leave the value at 40 mm and click OK to create the new flanges. Now that the new flanges are in place and aligned to the base plate, let's add the holes to the flanges. To do this, I'll start a new sketch on the bottom of the base plate and use the body option for projection so I don't have to pick the individual edges. Under the Create menu, along with Flange, you will find Extrude, Hole, and Thread tools, but since I projected the edges, I'll just use Extrude. We'll select the 4 circles for the extrusion profiles and pull them up until they go through the sheet metal part. You can also expand the Objects to Cut portion of the dialog to see that we will be cutting Body 2, which is the switch plate. We'll click OK to create the cuts and turn off the base plate to be able to clearly see the holes. The last thing we will do to this overall part is round off the exposed, sharp corners using the Fillet tool, which is in the Modify pull-down, just like it is in the Model workspace. We'll select the 4 small edges on the corners, avoiding the long edges of the part, and set the radius to 2 mm. After creating those fillets, I'll use the marking menu to restart the filling tool and select the sharp corners of the last 2 flanges that were created, this time using a radius of 5 millimeters. With the part largely finished, it's time to start creating some detail, which for this part means creating cutouts for switches. We'll start by creating a new sketch on the top of the part and using the 2-point rectangle tool from the sketch pull-down to create a small rectangle near the upper left corner. Now, we'll use parametric dimensions to set the width of the rectangle to 20 millimeters and the height to 10 millimeters. Then we'll add dimensions to set the rectangle 10 millimeters in from the side of the top face and 10 millimeters in from the edge of the top face. Next, we'll create a series of the shapes. I'll select the rectangular pattern tool from the sketch pull-down, roughly placing a 3x3 pattern. Now, let's add a 15 millimeter diameter circle and use the rectangular tool to create another 3x3 pattern of it as well. After creating the pattern, I'll go ahead and locate that initial circle by placing it 15 millimeters down from the upper edge and 45 millimeters from the right edge of a rectangle. Then we can extrude all of the holes through the switch plate. When extruding these holes, we need to take care not to use the All option so they don't go through the bottom flanges. We can use the object setting and select the bottom of the face we are going through, drag a distance, or enter the thickness value of the material. However, a good practice is to use a named parameter that controls the thickness to set the value. I'll click OK to create the features for now. To find the name of the value that establishes the thickness of the part, go to the Modify pull-down and select Change Parameters. The value of the thickness was given the name D9. To have something easier to remember, I'll create a user parameter named Thickness, noting the capitalization, and set the expression to 2 millimeters. Going back to the part, I'll edit the extrusion and change the distance value to -D9 or to -thickness and say OK to update the feature. Now let's save the file so we can proceed to the next lesson.